CNC machining is a key manufacturing process. The method involves the use of computerized systems to control machine tools and equipment to be able to create precise and complex parts and assemblies from a variety of materials. This video will explain 5 aspects to help you understand the basics of CNC machining. Remember to take notes carefully. If you are interested in CNC machining, please like and subscribe to my channel. The first commercial CNC machine can be traced back to the early 1950s, through the punch tape to operate, input data to control the process, improve processing accuracy and productivity. The introduction of this new technology quickly gained the attention of the manufacturing industry and recognition. CNC technology began to be widely used in industry. With the development of semiconductor and electronic technology, the CNC system upgrades, using digital and logic circuits for control. This CNC system can be programmed with high accuracy and repeatability, but the operation is still relatively cumbersome and not flexible enough. Further innovations in CNC technology in the 1990s. Digital controllers are integrated with computers. The computer calculates the instructions, the controller executes the instructions. This stage of the CNC system is not only more flexible in operation, but also can realize more complex processing tasks. With the progress of science and technology, the emergence of intelligent CNC systems, so that the machine tool can run automatically, but also according to the processing needs and materials and other factors, automatic adjustment and optimization, greatly improving the processing accuracy and efficiency. The development history of CNC technology fully reflects the continuous progress of science and technology. Common types include horizontal machining centers, 5-axis machining centers, gantry machining centers, vertical machining centers, etc. Lathe is mainly composed of the main body of the machine tool, touch control system, tools and auxiliary devices, etc. The main body of the machine tool is the core part of the touch control lathe, which consists of the bed, the storage axis box, the work table, the water intake mechanism, and so on. The bed is the supporting and fixing part of the lathe. It has enough rigidity and stability to withstand the cutting force and vibration. The spindle box, on the other hand, contains the spindle and the spindle drive unit. The spindle is the axis on which the tool is mounted, and the rotary motion is realized by the spindle drive unit. The table is the clamping and supporting part of the workpiece, which can realize the movement of the workpiece in different directions. Feed mechanism, control the feed movement of the tool relative to the workpiece, including longitudinal feed, transverse feed and air effect speed adjustment. These components of the CNC lathe with each other, together to achieve automation of CNC lathes, precision and high efficiency machining. In any CNC machining, computer-aided design, CAD, and computer-aided manufacturing, CAM, are one of the 2 types of software that play an important role in the overall operation, as they transform concepts into reality. CAD software is used to create detailed digital models and representations of parts or products. With the help of computer-aided design, 2D and 3D models can be created, accurately dimensioned, and incorporate various materials and textures. CAM software converts CAD models into machine-readable code, generating the instructions that CNC machines need to produce physical parts. It takes the digital design of the CAD and converts it into a series of toolpaths that specify the precise movements and operations that the CNC machine needs to perform. This covers details such as material removal techniques, tool changes and cutting speeds. A programming language called G-code is used in CNC machining to regulate the movements and functions of a CNC machine. It consists of a string of alphanumeric codes corresponding to certain commands that guide machine motion, tool placement, and action selection. G-code programming basics. 1. Command structure. G-code commands consist of letters and numbers, each representing a specific operation or parameter. Common letters include G, M, X, Y, Z, F, and S. For example, G01 may indicate a linear feed movement, while G00 may indicate a rapid positioning movement. 2. Motion instructions. G-codes are primarily concerned with controlling the motion of a CNC machine. Commands such as G00 and G01 specify the type of motion. G00, rapid positioning, moves the tool quickly to the specified position without cutting. G01, linear interpolation, guides the tool along a linear path at a controlled feed rate. 3. Coordinate system. G-codes use a coordinate system to specify the position of the tool relative to the workpiece. Typically, X, Y, and Z coordinates are used for three-dimensional machining. For example, X10Y20Z5 would command the machine to move the tool to a point, 10,20,5, on the appropriate axis. 4. Speed and feed control. The G-code includes commands to control the speed and feed rate of the cutting tool. F, feed rate, specifies the speed at which the tool moves along its path, indicating the distance traveled per unit of time. S, spindle speed, sets the spindle speed, which is critical for cutting operations. 5. Tool change and machining operations. G-code includes tool change instructions, M06, and various machining operations. For example, M03, spindle on, clockwise, activates the spindle in a clockwise direction. M05, spindle stop, stops spindle rotation. 6. Conditional statements and iterations. G-code allows conditional statements and iteration to enable more complex machining processes. This flexibility is essential for tasks such as cavity machining, drilling and contouring. 7. Safety and error handling. G-code can include commands for handling errors and ensuring safety in the machining process. For example, M02, end of program, marks the end of the program. M30, end of program and rewind, ends the program and returns the tool to the starting position. 1. Material hardness. Hardness affects the wear resistance of cutting tools. Softer materials require a smoother surface finish, while harder materials require additional surface finishes based on material hardness. 2. Tensile strength. Tensile strength is critical in determining how a material responds to cutting forces during machining. The material has a high tensile strength to help prevent tool wear. 3. Workpiece size and shape. The size and shape of the workpiece affects the choice of material. Some materials are better suited to specific geometries and sizes. In addition, the availability of raw materials in the desired size and form may affect the choice of material. 4. Cost considerations. Material cost plays an important role in manufacturing decisions. The CNC machinist must balance performance requirements with the economic feasibility of the selected material. Some projects may offer cost-effective alternatives without compromising quality. After reading the previous section, we may have some idea about the whole machining process. Next I will tell you the complete steps of machining. The first step is to design the CAD model and convert the CAD to CNC code. Step 2, machine setup, setting up the CNC machine for a specific machining job. Step 3, load CNC program, transfer the generated CNC code to the CNC machine control system. Step 4, machining operation, starts the CNC machine and executes the loaded program. The machine starts the milling, drilling, etc. manufacturing process according to the predefined program. The machine operator closely monitors the process and notifies if any problems occur. In the fifth step, quality control, after machining, A thorough quality control check is performed to verify the accuracy and quality of the machined part. CNC machining has revolutionized the industry by utilizing computer-controlled equipment to automatically perform complex and precise machining operations. As a key component of contemporary industrial production, it improves reproducibility, accuracy and efficiency. Through this video study is not more understanding of CNC machining. Let's talk about your thoughts in the comments section.